Hello class and welcome back. Today is November 23rd and we'll be going over how to solve cubic polynomials. Last time we went over your test and also the answers to your homework problems. We will be doing mostly long division, and tomorrow I'm going to introduce you guys to something called synthetic division. And that's going to be it for the remainder of the week because we meet today, Tuesday, and Wednesday, and that for a half day even, and that's it. So today we're going to be keeping it a little relatively short, and you're going to be seeing questions of the exact same nature as you see in the video. So for the first question, what you see, they're going to ask you, for each of the following cubic equation, one root is given. Determine the other roots of each cubic. All right, so I'm given a cubic equation, and it says that it has a root at x is equal to 2. Now, what is a root, you may ask? It's the fancy word for saying x-intercept. It's the number that you get when you were like solving for factors. You can say the root is at 1 and the root is at 2. But these are called factors, and these are called roots, or x-intercepts for that matter. All right, so now that we have the vocabulary terms out of the way, let's take a look. Okay, so now I have x equals to 2. If I put this in a factor form, what do I get? That would mean that it's x minus 2. Okay, so let's say supposedly I was able to factor this. Is x minus 2 one of those factors? That is really the essence of the question. Okay, so and that's all you're going to be checking for. Okay, so if you know that x minus 2 is one of the factors, that means that we can do long division to really check our answers with this. Okay, so how do I do that? So you take the cubic polynomial, x cubed plus 3x squared minus 6x minus 8, and you're going to divide that by x minus 2. You're going to do a long division with this. Now you're going to take some time and you're going to do yada yada yada, dot 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 dot. And if the remainder turns out to be a 0, then you know that it has to be a factor. Because if there's no remainder, like for example, 24 divided by 4, we all know 4 is a factor of 24. Why? Because you get a remainder of 0. It's the same exact reason. So I'm going to do long division with these two. X squared, I hope you guys didn't forget, how you do long division is that you always take the first term of each of these guys, so x cubed with x, and ask yourself, how many times can x fit in x cubed? X squared times. So you multiply these two together and you write it down here. Subtract these two, make sure you distribute the signs, cancel these out. 3x plus 2x gives you 5x squared. Bring down the minus 6x. How many times can x fit in 5x squared this time, plus 5x? So I'm going to write down 5x squared minus 10x, and I'm going to distribute the negative sign here and there. Cancel these out. I get 4x divided by my, bring down the minus 8. 4x and x, you can fit it 4 times. So that's 4x and it's minus 8. And what do you know? If you subtract that, you get a 0. So, is x minus 2 one of the factors? Yes, because the remainder is 0. And lo and behold, this part also, you can factor it, x plus 4, x plus 1. So technically, the entire factor for this one will look something like this. And you can say the roots are even at negative 2, negative 1, and negative 4. Okay. Try this question, pause the video, and if you're done with it, please let me know. All right, so I'm hoping that you have the answer here as a no, I believe. Has a root at x is equal to 3, which means it's x minus 3 divided by x cubed plus 2x squared minus 21x plus 18. So you can put x squared, x cubed minus 3x squared, 5x squared minus 21x plus 5x plus 5x squared minus 15x, and that will give me minus 6x plus 18. Actually, wait a minute. I do get the correct answer. Sorry, I was looking at the wrong answer key. So here, if you take a look at these two, oh, I'm sorry, not these two. If you were to multiply the minus 6 with plus 18, you get minus 6x plus 18 once you distribute them. So the answer here should be a yes, absolutely. And obviously this one can also be factored, x plus 6, x minus 1. So my other two roots would be these two. Sorry, it's not a no, it's a yes. Is x equals -2 a root of the equation for this one? Okay, so then this is the type of question that you will see for the second half, where it's asking you to figure out whether x equals -2 a root. Pretty much, it's going to be the same question as you've been doing before. It's the same yes or no question. So again, x plus 2, x cubed plus 9x squared plus 26x plus 24. And then you're going to do the long division with this. X squared, x cubed plus 2x squared, 7x squared, because I need to subtract these guys. Cancel these out. Bring down the plus 26x plus 7x here. 7x squared minus 14x, because I need to distribute the signs once again. That's 12x plus 24, and yes. That is an absolutely a yes. X plus 3 and x plus 4 is also another factors of those guys. So completely factorizing this should look like this. Okay. All right. So this is the question that I'm probably going to ask you again for homework. Today's video is going to, like I said, it's going to be really, really short. Is x equals 4 a root of the equation? Has a root at x equals 3? Determine the other roots of each cubic. This is what I really want you guys to get at, where if you are given a cubic function, can you completely factorize the entire thing? So once you factorize, once you divide by using the long division, whatever you do get as a quotient, please factor them out and make sure you get those two other x-intercepts if it's a possibility. If you do not, let's say you can't factor it, as long as you get a quadratic, you can always use quadratic formula to always find out the other two roots as well. But I think for the homework questions, you should get an integer values or fractions like 1/2 or 2/3. But that should be still factorable given the situation. Okay, so I think that's it for today. Make sure you have finished the work. If I ask you to completely factor, please factor them. Determine the other roots. And if it asks you to whether it's a root or not, use long division. And make sure that the remainder is equal to 0. If the remainder is equal to 0, then yes, it's factorable. And that means that it is a root, or you can say yes for the question above. Or if the remainder is not 0, then you can say no. It's not a root. That's all you have to remember. All right, hope you have a great day, and I'll see you guys tomorrow.